Thanks, Dave. Okay, so this morning, I'm sorry about my lighting. I look pretty dark in here now. I'm going to go through some activities that I've used with students and with teachers. Some of you may have seen these before, but I hope you get something out of going through them one more time. And for some of you, they will be new, I hope. So I'm going to start with oops, sorry. Okay, I'm going to start with this puzzle. Hopefully everyone can see this one that says at the top, use 0 through 9. And hopefully there are enough blank spots in here for the numbers 0 through 9. So we should see 10 blank squares. And your job is to figure out where the numbers 0 through 9 go in this puzzle. And when I do this in person with students or teachers, I give them actual tiles made out of paper or cardstock, and they can physically put the tiles in the puzzle where they think they belong. So why don't I open it up to, chime in if you have an idea, and then I can do the writing, or if you're able to, I don't know if you're able to write on this screen. Sorry, I'm not a Zoom expert.
So if you click the view options, there's something that says annotate. And if
Yes.
you click annotate, you can then write on Pam's screen.
Oh, everyone can. Okay, good. I'm thinking that everyone's trying to do it with pencil and paper, which is fine.
Pam, so we only use 0 and 9, right? Or any numbers from 0 to 9?
Good question. I'm glad you asked that. So 0 through 9.
Okay, thank you.
And there are 10 blank spots. So you want to use each digit exactly one time.
Okay.
Thanks for that question.
If you weren't monitoring the chat, Joanne typed 9 equals 2 plus 3 plus 4 in the chat.
Oh, I did not see that.
And then Jacqueline just put 3 plus 0 equals 10 minus 7.
For some reason, when we switched over to me, I'm not sure how to get back to the chat, Dave.
Oh, so I can monitor the chat. Do you want me to put these in and annotate the ones from the chat onto your screen? I can do that.
If you don't mind, because
Yeah, not at all.
For some reason, I can't see the chat right now.
Sure. I'm writing with the mouse, and so.
Yeah, I will be too.
So do people see other things to fill in? You can shout them out. One times 2 is 3 minus 1. Is the intent here that each number is used only once?
Yes.
And so when you say 16 minus 7, I think 16 is not between 0 and 9. 8 minus 7 is 0 plus 1, but the trouble with that is we've already used 0 here. So maybe 2 times 2 is 5 minus 1, 7 plus 3 equals 4 plus 6 equals 9 plus 1. Where is that? Right, so if we use a set, so a little bit, 9 minus 2. Where did I see? I don't see where the 9 minus 2 is.
There's a 9 equals.
Oops.
So.
9 minus. So let's maybe look at things where we have a unique possibility versus the ones where we have an only. Like here, we've got 2 times 2 equals 5 minus 1. And so let me put a 2 and a 5. Let me make this a 3 and put a comma here. Let me put a 1 and a comma, The difference here is I don't know whether the solution is to use 1 and 3 or 2 and 5 yet, but those are certainly possible numbers.
Could I ask, are of the numbers that are in the boxes now, are we absolutely positively sure of any of them? And if so, which one or ones?
You almost have to start with the bottom one because it gives you 4 plus 6 in the middle, which means both of the equations on each side of it have to add up to 10.
Okay, so Ginger, is there something you would put in a box?
So I
right now?
put 8 plus 2 equals 4 plus 6 equals 9 plus 1. So that takes care of the 8, the 2, and the 9.
And you're absolutely sure of every one of those numbers?
Let's see, 8 plus 2. From this angle, yeah, but the more I think about it, and when you ask that, I don't know.
It's
point
just a
is-
question.
Is
I
8
think-
plus 2 the only way to get 10?
And are you absolutely sure that 9 belongs over here? I'm not sure if you can see my cursor, but the blank plus 1 on the bottom, are you absolutely sure that's a 9? You're muted, Ginger.
I do believe that that one would be 9, but you're right. There could be a different variation on the first two.
Okay, so you're absolutely sure of this,
Mhm.
and Dave put a check mark up here, which I think means he's absolutely sure that that is a 4. Is everybody absolutely sure that this 4 has to go here?
Yes.
Okay, so I think what Dave and I are both kind of trying to get at is for a couple of these, there's absolutely no question what belongs there. So would that be a good place to start a puzzle like this? So we can talk about a term called entry points. So those two places might be entry points, good entry points for this puzzle. And then you can go from there, the 4 and 9 having been used up already.
At the bottom, that last one, the 8 and 7, we
Mhm.
already used the 7 on top. So 7 and 3 won't work, right?
Well, did we use 7 for sure on top, or was that just a possibility?
Okay, I was just wondering because I saw 7 and then I saw 7 on top. Just a thought.
Well, you're certainly right that we cannot use the 7 in more than one place. But as Dave pointed out, I'm not sure we're 100% certain about the possibilities for the top. Maybe there are other possibilities.
Also, can somebody explain why this 4 has to be a 4?
That's the only number that will, if you will add up the equation 2 plus 3 plus 4, that's the only number that will equal to 9. So you need to get equivalent number both sides so that to make the equation true.
Somebody put an arrow over here. Why is there an arrow over here? So what about that box?
What if we put a 2 in there?
Laura's speaking but is muted.
Oh, sorry.
I'm thinking out loud, sorry. I can't, you mean where the arrow is?
Yes.
To put a 2 there?
Yeah. Is that make sense?
Lower level, we don't do negative numbers, so.
Yeah. And using the numbers 0 through 9, you're not going to do something +1 and get a negative number.
Well, but if you put 2 minus, you can put 2 plus 1.
Right. But the point is, if you put a 2 over here in the 7, you'd get a negative number.
Right.
So this is the Sherlock Holmes. If you cancel out what's impossible, you'll be left with the possible. Another thing I tell my students is I don't have a trap door. I can't pull a lever and drop them into a pit. There's no harm for trying something. Just everybody shout out a number. Somebody pick a number is what I'll say. And so if I was going to illustrate this, I'd say, Joanne, I see somebody put something in the chat, but Joanne, tell me a number. Doesn't matter whether it's right or wrong. It can't hurt you over Zoom, right?
Right.
So tell me a number.
8.
8. And so let's try 8. If we had 8 minus 7, what's that equal to?
1.
1.
And so then if I want to get something plus 1, could I put something in here and make this work?
0.
Sure. So that's a possibility. Let's test another number just to see what happens. And so, Virgilin, can you tell me another number?
9.
9.
Use 9 because 9 is at the bottom.
So I can write here a 9 and I can draw an X through it because it's not possible because we had to use a 9 here.
Very good.
And if you use any other number, it's going to be, you're going to end up with a negative. And I agree with Ginger, at the lower level, we do not teach negative numbers.
Sure.
It's not introduced. So yeah,
So
you
it
gotta
has
be
to-
a magician and pull a rabbit out of baseball cap and you got it. I don't know.
I'm thinking that it's 8 minus 7 equals 0 plus 1 because the possibilities were 8 and 7 and we crossed out the 7.
Yeah. And we, in fact,
Process of elimination or logical reasoning, whatever it is.
Exactly. And mathematicians love that logic. That's some of the most important stuff we've got here. So in fact, I can upgrade this from a guess column to a check.
The bottom row, you're going to have to use the 7 and 3 because you have 8 here.
Right.
And then on the top, it's going to change the 0 and a 7 because you already used 8. So the bottom will be 7 and 3.
Nice job. Good points.
So we use 3, 0,
1.
8. That leaves us with 1, 2, 5, and 6. Let's see. 3, 5.
Can we do a process of elimination on this guy in the second row?
Yes, because then it would make the top one 3 plus, so I had it in my head and then I lost it. 3 plus 6 equals 10 minus 1.
And is that a possibility or a must? Or it looks like we might have a way of filling things in. We have a way to fill things in.
Well, that's using all of the digits. 0, 1, 2, 3, 4, 6, 7, 8, 9. Well, if we use any of the others, because 6 times 2 is 12, and that's that wouldn't work. 1 times 2 is 2, but then we'd have already used our 3, so that wouldn't work. So yeah, I'd say that's where it goes. That's the logical answer.
Awesome. And in fact, you just not only found a solution, but you proved that that was the only solution because you did the Sherlock Holmes cancel out the other possibilities.
Yeah, I do a lot of process of elimination with my second grade because that's the only way they can see it that way.
Yeah. I think Pam will send me this and I can post it to our
Good.
site so you can share this with your students.
I guess
think we could also swap around the 1 and the 6 on the top row, because 3 plus 1 would be 4, and then 10 minus 6 would be 4 as well.
You're right. You're right.
So just another like option there, which is kind of cool that there's more than one solution.
Mm-hmm. Are there any other swaps that we could possibly do?
You mean within a row?
Mm-hmm. Mm-hmm.
So
Where does the 3 go? Go down here.
without getting negative numbers.
And this would be a good time to talk about or bring up with your students the commutative property.
Right.
Not for the top one necessarily, but another one. There you go. Dave just pointed it out.
Oh, okay, I see.
Okay, nice job.
I'm incredibly tempted to add something here that's very similar to this that I think is critical for lower level teachers to show. Let me just write one equation. Sorry, Pam, I hope I'm not
That's fine,
breaking
Dave.
your flow. So fractions are almost considered like a bogeyman in math in middle school grades, where sometimes people have a lot of trouble understanding it. Part of it is that there is the fact that it's not exactly unique. You can write 2/3 is the same as 4/6 because we can multiply the top and bottom by the same thing. A really important warm-up exercise for that is when students are learning single-digit subtraction, I feel that they should see that they can add the same number to each side and still have the same difference. You can do this with piles of pebbles or piles of rocks. If I have 7 take away 2, that's the same as 8 take away 3. Right? If I have the total pile of things for the class and how much I'm giving somebody who takes as tax, if I add 1 to this pile and 1 to this pile, we still have the same leftover amount. If you see what I mean, this process is exactly the same as this process here. Here, we're multiplying the top and bottom by the same thing. So when we divide, the answer doesn't change. Here, if I add the same number to both parts and then subtract, the number doesn't stay the same.
And I like to think of that difference as a distance. So if you think of it as how far apart are 7 and 2 on the number line, if you just move both of those numbers up 1 spot on that number line, the distance remains the same. You can move, in fact, you can add 2 to both numbers. Then my new subtraction problem would be 9 minus 4, which again has that same distance because I'm just moving that distance on the number line up the number line or down the number line. That distance remains the same. So I have some comments about this activity, but first I'd like to open it up to you all and ask, and again, I can't see the chat for some reason, but maybe Dave can tell me what's in it. What grade level do you think this particular puzzle would be appropriate for? Or grade levels?
My level.
Meaning, oh, meaning David Holly's level. Okay.
You know, it's hard. You got to know all the operations ahead of time, obviously.
Yep. Yep. Oh, maybe that wasn't David. Sorry, I'm not sure who that was.
Yes, it was.
Oh, it was. Okay.
He's the lamp.
Okay. The ceiling lamp. Okay. Other thoughts about grade level for this?
I think perhaps 3rd on up because they start learning multiplications. And if you're going to use it for like 1st or 2nd, you probably wouldn't use a multiplication in there. You
Okay.
could change it and challenge them.
Uh-huh. Okay.
My thought was that they could do everything but that one, and then they'd end up with that one as the last.
Mm-hmm.
I know my class this year, we did a lot of multiplication in the last quarter. So I think in 2nd grade, it is capable depending on the level of the kids
Oh, okay. Okay.
and the understanding of the kids.
I agree. I think 2nd grade can probably handle it because they do multiplication. And some kindergarten, depending on what math program they're using.
Oh, wow. Okay.
One of the things that I like to challenge people with is how can you turn the knob and make this problem easier? We've already got a hint with that, but give me ideas to make this puzzle easier.
Fewer choices.
Yeah. And so instead of the numbers 0 through 9, you could use the numbers 0 through 5. And we saw another one where somebody said, don't do multiplication. My students haven't seen multiplication.
Yeah, and I have another one queued up along those lines.
How could you make the problem harder?
Hmm.
Division.
Yeah, absolutely. Add division. Add
I would
fraction.
say use some things like this.
Fraction.
Yeah, fractions, yeah.
I'm thinking this would work perfectly for gifted and talented students. I'm gonna try this fall.
Oh, great.
This would be a great test to see if they are gifted and talented. To see time them, how fast can you do this?
Another really important thing is giving people problems that they haven't seen that require no background. I think almost all of us would be in the same boat if somebody said, make a puzzle like this. Because I've never had to make a puzzle like this. So as a professional mathematician, I have to sit down from scratch and start thinking. I don't have an advantage. It's very possible that if we made that the puzzle, Marge would come up with a puzzle before I would, simply because I have no advantage over Marge. This is a really nice thing when you want to build confidence in students, because you're then not seeing some student that's had better background is doing better, and some student that's struggling feels bad about themselves, because you just sort of open it up to make your own puzzle and nobody knows how to do it. So everybody has the possibility to succeed.
Yes, I would strongly encourage teachers to make their own puzzles geared towards whatever content you want to focus on. And I would also encourage you to ask your students if they can make puzzles. And you all know as teachers that students like to do that kind of a thing, especially if they feel like they might stump the teacher or make the teacher really think about how to solve their puzzle. That's always fun for them. And you could always perhaps put their name on the puzzle and laminate it or something, and have that be part of your classroom collection of puzzles. And they will be really proud to have contributed to your stack of tile trial puzzles. And again, that name, I'll just write it on here. And again, when I do this with students or teachers, I would use tiles, number tiles that they can easily move. So maybe they had a 0 in the top equation and then they realized later they need the 0 somewhere else. It's very easy for them to just simply move the tile from top down to the 4th equation. And they don't have to erase lots of times. Some of you, if you were doing it today with pencil and paper, you might have been frustrated at doing some erasing and figuring out what have you used and what haven't you used. If you have tiles and 3 of them have already used, it's very obvious that they're the ones that are used and are no longer accessible. And Dave mentioned you want to show students puzzles or problems that they don't normally see. So I would ask you teachers to look at my 5 equations. Are there some of those that students would just not normally see in a textbook or on a standard worksheet? Which ones of those might look just rather different than students would normally see?
Well, the second one with multiplication and subtraction, because in 2nd grade, like we said, we don't use those in tandem, not until the end of the year.
Okay. Okay. So maybe that's the one that stands out as kind of a different kind of problem that students You don't normally see probably different operations mixed in, maybe addition and subtraction, but probably not addition, subtraction, and multiplication, division. A couple other comments I have, and then I'll move on and show you a different tile trials puzzle. I'd like to look at this one. And I don't know if I can, yeah, I can erase what Dave wrote in here. So if you look at that second equation, and it's not terribly important to know what we've used already and what's still available, but if you just look at this, there's something that might pop up in this equation that might be of interest to students or teachers and might help students with possibilities. So when you multiply something by 2, what kind of numbers will you get?
Even numbers?
You'll get an even number. Okay, nice. So if this result is even, how would I make this result even? What kind of number would I have to put in here?
Odd.
Odd number?
Yeah, I'd have to put an odd number in there to make this thing work. No matter what I put in here, this result's going to be even, and thus this has to be an odd number. And then the student could think about, well, 1, 3, 5, 7, 9, which ones of those are still available for me? So that might help. And so that might be a way to have a discussion in the classroom about evens and odds. And and multiplication by 2 is the thing that brought us there to that discussion. So okay, any other comments on this one before I show you a different one? Okay, so as Dave mentioned earlier, we could make an easier puzzle. So this one just requires 0 through 4. So 0, 1, 2, 3, 4. Is there a place that we should start? And again, I can't see the chat, so feel free to either write something in there yourself or say it out loud and I can do the writing.
Let's try this all together. Everybody shout a number.
You see any place that has to have, there's only one thing that works in there. Gwendolyn? I can't.
I think the easiest could be that 3 is greater than the 2 boxes. It could be 3 is greater than 0 and 1, or 0 and 2.
Yep.
But you have to still work around with the others.
Okay, nice. So you're saying this could be 0 and 1 or 0 and 2, if I heard you
Yes.
correct. Okay,
Yes.
nice. Is there anything that we're absolutely sure about 100%?
Well, the first one, the box is going to be 0, 1, or 2.
The first one could be 4, definitely, because 4 is greater than.
Oh, it's greater than. Okay.
Yeah,
I'm dyslexic this morning. Sorry.
Oh, no problem.
it's Saturday.
Thank
Okay,
you.
I
And
think
had
when
enough
you're
coffee.
I think when you're starting this problem, you'd have to start with the top first, because you're
Okay.
only using numbers from 0 to 4. And like it was mentioned, 4 is the only number that would go here because it's
Mhm.
greater than 3.
One is a
Okay.
given.
Nice.
That was simple.
Are we done?
No.
Now
Well, then we can't use 4 down here in the bottom.
yeah, and based on what Gwendolyn said, we're definitely using 0 in the second equation.
So you might use a 1 and 3 at the bottom.
One and three.
I don't know whose 4 and 0 are in the box there. If somebody erases,
Then the 2 would fit with the 0 at the top, the middle.
That's what I was thinking, is 3 is greater than 0 plus 2 or 2 plus 0. And that makes 3 plus 1 equals 7 minus 3.
Then you can use the 1 and 3 at the bottom.
and does it have to be 1 and 3?
No, it's the middle one. 1 and 3.
But 3 has to
No.
be greater than the combination of those two numbers.
Yeah, you're right. So it'll be 0 and 1. So which is going to be 2. No. 3 and 1.
Yes. Those could go back and forth. The 1 and the 3 could go back and forth, and the 0 and the 2 could go back and forth.
Mm-hmm. Okay, nicely done. So again, it sounds like most of us agree that the place to start this puzzle is the top. Because that one is a for sure, there's only one thing that works there. Unless it's early on a Saturday morning and you're not reading the inequality sign correctly. That's okay, that's okay.
Those alligator mouths get me every time.
Couple comments. What do you notice about these two numbers in these boxes, the 1 and the 3? What do they add up to?
4.
4. Is there a 4 here?
Oh, yeah. 7 minus 3.
Just pointing that out. I guess we can see if that works every time. And if so, why? So grade level for this puzzle.
Third.
Third, okay. And
I
when
think
did,
second and third, if they're working together and talking through. And I think what would help is if you have number tiles
oh yeah,
and move them around, see if which ones work.
I've had
Yeah.
first graders that could probably do this too.
Okay, they know their inequalities or learning them? Okay,
I agree that first grade could do it. Maybe you could introduce the first and second row. And then later in the year, you could do the last row and introduce it that way, because they do inequalities in first grade.
okay. And again, with these tile trials, the sky's the limit pretty much. I mean, yep, you do have to be careful. It's pretty easy to make them challenging, maybe more challenging than you intended. So you have to be a little careful. You might think that if there are a lot of blank spots in one equation, that makes it easier, but it actually makes it harder, right? Because, you know, if there's a lot of possibilities, then it really doesn't help the student solve the rest of the puzzle. They want to find places where there are limited possibilities to get started. So, you know, I would encourage you to play around with making some of these at your particular grade level, at, you know, focusing on perhaps things that that trip students up and they need practice. I can tell you from using this with students that they really, 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 really like them. What I normally do when I visit a class is have maybe 8 of these prepared for them, and I put them on at the side of the classroom. I start them off with the first one, give them their tiles. When they've arranged their tiles, they're ready for me or the classroom teacher to check their work. We give them the thumbs up. They dump off their tiles. They return puzzle number 1. If they grab puzzle number 2, go back to their seat and start working on that one. And they really like it. It can become a bit competitive, and maybe you don't want that to happen. You don't want them to rush through it necessarily. So you might want to keep an eye on that.
I'm thinking this is a good also activity, because to try and show the importance of learning their math facts, because that's what we're seeing issue with, is the kids not retaining their math facts. And so I think if they can see it used in a different way than just flashcards or something like that, it might be.
Mhm. Or the traditional worksheet approach. Yeah, and I wanted to point out when we were all trying to solve the first puzzle, think to yourself how many math problems you did in your head as you were trying to figure it out. You did all kinds of possible, you know, 2 minus 3, 5 minus 2, 7 minus 9. You did all of those in your head as you were trying to figure out where to get started with the puzzle. So there's a lot of mental math going on. And Ginger, I'm really glad you brought up that point, because all of my activities today are kind of focused on number facts, number fluency, number flexibility, and this thing I like to call play with numbers. And I don't mean play like in a silly way, like, but a very intentional, let students play with numbers and see what happens. And I think the tiles actually is kind of an element of play. You know, these are just tiles. I'm just moving them around and see what happens, rather than the pressure of, I'm using my pencil and I'm writing this in and I hope it's right because I don't want to erase 10 numbers on my page if I'm wrong. I have one other comment to make about the last tile trials puzzle. So let me bring that up again. Oops, wrong one. There we go. Okay. I want to focus on a couple of these. This is a really tough thing that some students have, that some students encounter when doing these puzzles. For instance, we could focus on this. Sorry, that's not a good one to focus on. Let me change my mind here. I'm going to look at this down here. Tell me what you think a lot of students would want to put in that box.
10,
What was that, Ginger?
10,
10. Why would they want to put a 10 there?
because 4 plus 6 is 10.
Exactly. And I have done lots of these with many students, and I find it pretty challenging to convince them that they absolutely need to look at this entire right-hand side. This sum has to be 10.
That's why it's so important to make sure that the unknown is not always the answer.
Exactly, exactly. I'm so glad you said that. So you can do your students a huge favor by mixing up the visual look of a lot of these equations. Sometimes the answer is going to be on the left-hand side. Maybe there is an unknown on both sides.
I had a something, what was it, I think it was this year. It was a math lesson where I had the difference on the left, the answer, and then the problem, and I had teachers coming back over to me, that's not right. And I went, yes, it is.
Oh my.
Yeah, so I had to bring up the state standards and show them table 1.
Oh God.
And let them know. So it's even something that some adults need to. And with this virtual learning, we had parents that were just constantly calling, going, "How do I do this?" You know,
Oh,
and
yeah.
it's just like it's simple equation. You just have to look at it a different way.
So I think I'll just emphasize again, you can do your students huge favors going forward. I mean, you might not see the results of it, but trust me, the teachers at a couple of grade levels beyond you, when they get those students, they will see the benefits of presenting problems like this and doing your best to teach the students that what this sign actually means. You know, and you have to look at everything on the left-hand side, everything on the right-hand side. It also helps when students get to algebra, when they're able to read an equation left to right, and also right to left. That's the beauty of that equal sign. You can read that equation in both directions. And if they've been seeing this for many years before algebra, they'll be in a much better place. Any final comments about tile trials?
I'd like to make one. I've seen versions of this that could be done with refrigerator magnets, which you can, when they used to send you phone books, you sometimes would get sheets of magnets, or you could find sheets of magnets, or they could be used on whiteboards, where you give essentially Cuisenaire or odds. So you have 1 square or 2 squares put together, 3, 4, 5. And a simple puzzle is just given a rectangle that's a 1 by 7 rectangle, how can you fill it up using 1 by 1 or 1 by 2 or 1 by 3 or 1 by 4? So you could put a 3 by 1 and a 4 by 1 to make a 7 by 1. This is allowing you to play really tactilely and get a feel for what's happening with the numbers and the links. You can do similar things in rectangular grids to get a flavor for multiplication before you're actually doing it with numbers, just with the shapes.
And by the way, some of you have seen me demonstrate these puzzles with those magnets. So I do get those magnets, cover it with a piece of paper with a 3 on it, tape it onto that magnet. And so those are my tiles that I use on your whiteboard in your classroom. And I invite the students to come up and put those tiles where they think they go on the puzzle on the board. So works really well. And last thing, I should give credit to, and I hope I'm spelling her name right. With an R. I think she spells her name with an I. So she, last I checked anyway, she has a website and she produces these puzzles called Tile Trials. You can buy her collections, or she has whole collections in books. I think she has a few free samples on her website, but then after that you need to purchase them. Just looking at her website might give you some more ideas. If it were me with a very limited budget in my classroom, I would probably make my own puzzles and have my students help me. But this is where I first got the idea for the activity. And I keep saying one last thing, but maybe this is my last thing. You can also use words. So if your first graders are still struggling with recognizing this word, use that instead of the numeral. So that might be something to add to one of your puzzles. Okay, moving on. Hopefully everybody can see my whiteboard now. So if we think of this as one number, 6,512, this is a number that a lot of people in my town recognize. Does anyone know why people in Durango, Colorado might recognize this number?
It's our elevation.
Yes, yes. Yes, Durango is 6,512 feet above sea level. So that's why I picked this number. But now for the purposes of this puzzle, I'm going to think of them as individual digits. So I see a 6 and a 5 and a 1 and a 2. And your challenge is to try to use these 4 digits. You must use each digit exactly once. And I want you to get 24. You are allowed to add, subtract, multiply, divide. You do not have to use all operations, but you may. You can rearrange those 4 numbers. But again, you have to use each number exactly once. Questions about the rules, what's allowed? So if you think you have a solution, please say it out loud and I can do some annotating on the whiteboard.
So like, for instance, we can use 12 times 2, which is 24. Is that what we're doing?
Yes, you can do that. If you can figure out a way to get a 12 from those numbers. Do you have a way?
Oh, I was thinking 1 and 2. I see what you're saying. 6 times 2 will be 12.
Okay.
That's another number. So 2, actually, no. Maybe
6
5
plus
plus
5 plus 1.
Yes.
Oh, okay. So if we do this,
Yeah, 6 plus 5 plus 1 times 2.
Bingo.
Nice. And by the way, do I need parentheses in there or not?
Yeah.
For the multiplication portion.
I'm not good at algebra. That's why I teach primary.
It'll be 1 times 2, the parentheses.
Oh, you want parentheses around this?
Yes, 6 plus 2.
Would that work?
That makes it 11 times 2. The parentheses need to be around the 2.
What do you mean around the 2?
Well, no, I mean around the 6 plus 5 plus 1.
Oh, okay. What if I have no parentheses? What would I do first?
Add.
Would I?
First.
2 times 1 for no parentheses.
Ashley, sorry, what was that?
If you had no parentheses, it would be 2 times 1 first because of order
Why?
of
Yes.
operations.
Okay, because we do multiplication before addition, subtraction. Yeah, so if I left this with no parentheses, this would be done first, so I get a 2, and then plus the 5 plus the 6, which would not get me to 24. So if you want me to add the 6 and 5 and 1 first, those need parentheses. I need parentheses around that.
Yes, that alleviates the confusion, yes.
Does anyone have a different way to get to 24 with these numbers? And remember, you can mix up the order. You don't have to start with the 6. And think about all the math problems all of you are doing right now, even without a worksheet in front of you.
I have 3 times 6 in parentheses plus 6. I don't, oh, what did I do? I know I did something. 3 times 6 is 18.
And you got
Oh,
the
I
3.
used 6.
Did you get the 3
And then
from?
I think I added 5 plus 1 to give me a 6, which I've added to make 24.
Where did you get the 3? From here? To the 5?
This is Saturday morning.
That's okay.
Let me keep working on it.
Okay, no problem. I didn't actually say there's another way. I just asked if anyone has another way.
-30 minus 6 would be 6 times 5 minus,
But then you're using the 6 twice.
and then okay, that's not going to work. Somehow I thought I got it. Sorry.
That's okay. That's okay. Ashley, not to put you on the spot, but I think you know of one other way, right?
I do. It's
Don't-
in
wait,
parentheses.
wait,
Oh, sorry.
wait. Just tell me the first thing you would do, the first operation.
6 minus 2.
Okay, thank you. So Ashley just gave us a hint, and 6 minus 2 is 4. Now,
4.
can anyone else finish it from there?
5 plus 1, which is going to be 6, 6, and then multiply that to 4. So it'll be 24.
Nice. Excellent. Okay. So that's one thing you can do in a classroom. You can give, one hint perhaps, or a student could give one hint just as a starting place and see if other people can finish it. And I can't remember if there was another way we came up with, Ashley, or not.
I thought we just came up with 2,
Okay.
but
Okay, that could be. Does anybody notice a difference how I wrote it over here versus how I wrote it over here?
There's 3 numbers for the first one and 1 digit number to multiply. And then here is 2 numbers multiplying, or actually adding, and then multiplying again.
Okay, okay. Did I actually write any operations over here? No. And I even ignored something that Ashley said right at the beginning. She said parentheses, and I ignored that. Because, and I just want to make the point that this activity in my mind isn't always about order of operations. If you want it to be about order of operations, then by all means have this discussion that we had over here. Do we need parentheses, and if so, why and where? So that could lead to that discussion. But to me, the most important thing about this activity is just that number fluency and playing around with numbers, because you want your students to be able to simply play around with these 4 numbers. What could I make here? I could make a 3, I could make a 10, I could make a -3, I could make a 2/5, if they're at that level. Then I could multiply it by 1. I could get, so all 3 of these could get me a 10 or an 8, or, and just all of this number flexibility and number fluency. That's what you want to get out of this activity, in my mind. And this game is called 24 because the target number is always 24. You don't want to change the target number. And one reason I like this target number, there are lots of ways to get there. And so students will learn to be on the lookout for 6s and 4s, for 8s and 3s, for 12s and 2s, for 20s and 4s, all those different ways they can get to 24. Now, I know some of you are probably thinking this is way beyond 2nd grade, for example, definitely way beyond 1st grade. So as Dave asked about my previous activity, how could we make this easier? How could we make this more appropriate for 1st graders and 2nd graders?
Change the target number.
Oh, change the target number. Yeah, sure. Do you have a suggestion?
Just start with, a lower number and so that they're using, simple, addition to
Okay,
get to it,
okay,
addition or subtraction.
sure.
Kind of ease them into the 24.
Do you have a suggestion or anyone for target number?
How about 12?
I like it. Uh-oh. I included multiplication again, didn't I?
Mm,
Okay, can one of you guys, can you give me a puzzle, say with 3 numbers perhaps? Should we just do 3 numbers? Give me a set of 3 numbers which they can use to get me 12, to get
4,
12.
6.
2, 4, 6. Okay,
Because even at the, early second grade, we get kids that don't know their, like I said, simple facts, and that's what we're working towards.
sure.
So the first
Yep.
thing they need to know is that 2 plus 4 equals 6, and 6 plus 6 is a double, which adds up to 12.
And simplifying the 12 to 2, 4, 6. Yeah.
Mm-hmm.
And you could also have a discussion, what if someone else suggests, oh, I added these 2 first,
Yeah.
and then the 2. Is that wrong? Is that different? Why do I get the same answer?
Nope.
You know, so you can have great discussions about that. And then, you know, as you progress with these, maybe some of your second graders could start thinking about multiplication.
Mm-hmm.
Oh, I think that has 2 different ways to get to 12, does it?
8 plus 2 plus 2. Okay. 8 plus 2 is 10 plus 2. Mm-hmm. And then 4 plus 8. Mm-hmm.
Yeah, so you could either add or multiply these.
Right.
Yes.
And I know of teachers who use this activity to start off a class, start off a math class, just, you know, 5 minutes on a 24 puzzle or a 12 puzzle. Or if you find at the end of class, you have 5 extra minutes, try to do one of these 24 puzzles.
That's
And
what
it-
I was thinking as an anticipatory set. Just put it up
Uh-huh.
on the board, and while they're getting ready, have them do it.
Yep. Yeah, yep. And you can actually buy the game called 24. It does exist out there. You could Google it. And very simply, it's just cards with these numbers on the cards. So there's really no need to buy it unless you really want to. You could certainly make your own. And again, this is a time for you to switch it around and ask your students, can you come up with some 12 puzzles for me? Can you come up with some 24 puzzles for me? And I know it's a little challenging to do this sometimes, but while you're doing activities like this, in a setting like this, try to step back and think, okay, where's the math that I'm doing? How much math am I doing? How would this be beneficial to students? And I would hazard to guess that you all collectively just did hundreds of math problems, mostly mentally, without me saying, do this worksheet. Okay, you're done with that worksheet, here's another worksheet. And to me, it has some element of play in it. which I like. Other comments? Who's going to try this in the fall? Who's going to try this with their children at home, Ashley?
I already have. They love it.
Oh, great. And what grade level?
Third grade and sixth grade.
Excellent.
But we're also doing how many numbers can you make too.
Oh.
Just they like to compete, and it's a good way for me to like keep tally with the two different age levels. So whoever can make the most addition, subtraction, multiplication problems out of those numbers wins.
Oh, I'm so glad you mentioned that, because Ashley and I talked about this last week and I forgot to mention it today. So there might be some students who just are not engaging in this problem because they're letting the smart kids figure it out, or the ones who like to talk more, and they're just not going to engage. So one way you could open it up is, instead of focusing on a target number, simply say, what numbers can you get? Just any numbers. Can you get a 9 from these numbers? Can you get a 1? Show me how you can get a 1. What's the highest number you can get from these numbers? Can anyone get a 20? What's the lowest number? Can we get negative numbers? And with problems like these, you might accidentally get into a discussion about negative numbers. I was told in first grade, we cannot subtract 6 minus 7, just can't happen. And then I found out later, oh, you can do that. And so I felt like I was sort of lied to in a way, that it's not that it's impossible. It's not impossible. And it would have been kind of fun to at least talk about the possibility in first grade, even though it wasn't in our curriculum. But simply open it up to what kind of results can you get using those 3 numbers, using these 3 numbers. So thanks for mentioning that, Ashley. Other comments? I think I have time to quickly show you one other activity. This is so far down on my paper. Not sure how I'm going to scroll this out. Oh, it does work. Okay. Okay, so, except I can't go to my annotation when I do them. There we go. Sorry, technical difficulties. I'm going to do it on the whiteboard instead. Okay. Is Jacqueline, can you give me a number, please?
0 through 9, or just any number?
Any number.
Go. 3.
Okay, thank you. And Shirin, I'm not sure if I said that correctly. Can you give me a number, please?
7.
Thank you.
You're welcome.
And Carol, a number, please. How about Marge?
How high can the number be? 24?
Sorry, say that, 24?
24, yes.
Okay, that's perfect. Okay, and David Holly, a number, please.
I didn't catch that.
Could you give me a number, please?
2.
Okay, thank you.
Two there.
Sorry, I'm drawing with my mouse, so not going to be great drawing. Okay, I need for you all to subtract the numbers at the corners and give me the positive result. So I want you to subtract 3 and 2, 2 and 24, 7 and 24, and 7 and 3. So what should go here up top?
4.
Good. And again, I always want the positive result. How about over here on the right-hand side?
17.
17.
Okay. Down on the bottom?
23.
22.
22. Yeah, 22.
22.
Okay. And on the side, left-hand side?
1.
Okay. I'm going to join these. And I want you to do the same thing using the 4 most recent numbers that I wrote down. So what goes here?
5.
5.
Over here?
20. I know. 20.
21.
3.
Okay.
13.
13.
Oops, missed that dot. Oh, well. Are we doing math? Where's the math we're doing? What level is it?
First. Second.
We're second.
How about first grade?
Okay, right-hand side,
8.
bottom,
16.
16.
If you're looking for fluency, I think it's going to be second grade.
second
18.
grade. 18 in the top.
And
10.
Okay. Anyone wondering what's going to happen?
We're gonna run out of space.
Yes, but when? When will that happen? Ginger's nervous, but it's going to happen pretty soon. Over here, left-hand side.
2. 8. 2.
2. 8.
Wow. 8.
Oh, interesting.
This is interesting. It's a pattern.
Come up with the same
Wow.
answer.
6.
6 all the way around. So we end up with 0.
Yeah. Oh my God. Awesome.
So should we keep going after the zeros? What would happen?
Your
So
negatives?
It'll be negative.
0, 0, 0, 0, 0.
It would just be 0.
Yeah, I would just get zeros, I think, forever.
Just put a 0 right in the middle.
Yeah.
So I might as well stop because I guess it kind of stops being interesting after that point. So Ashley and I did one of these last week together, and same thing happened. I forget how many iterations we had to do before we got to zeros, but we did get to zeros.
So what is the difference between this? I mean, is this the one that we would be doing on that grid you showed originally?
Yeah, I mean, it's just a little bit neater on a grid rather than freehand drawing. But you don't have to use a grid. If your students are trying to freehand draw it, they might have a challenge keeping everything straight, you know.
But this would be fun for the younger grades to do together too.
Sure.
Because there would be modeling from the higher kids to the lower kids as to what's happening.
Let me add some comments. One comment that can add, quote, color to it is let them pick different colors for different numbers and color each triangle according to the number on the outer furthest vertex from it. That way they can get a pretty pattern. Another comment is, does it always lead to zeros? In fact, it always leads to zeros when you start with integers, and there's one argument for that. If you start with random numbers, I was gonna say, is it only used for subtraction? Absolutely not. You could do the same thing with division or with multiplication or other operations. You don't have to start with a square. Phil Yaskin is a professor at Texas A&M, and he thought about it with some of his students and came up with a number of variations and a number of questions. You can get, this goes from first, second grade, where you're just learning to subtract single digits, up to research mathematicians. This is what we call a low floor, high ceiling activity. You can ask questions about it that can make anybody think.